Hey guys, I am going to do lesson 2.12 with you all. Luckily, this one is pretty algebraic and not too bad, and there are lots of videos on YouTube should you need more help. So, we've been talking about logs, and we're going to practice rewriting logs in different forms. And there's three properties we're going to talk about. So, for example, the product property. If you have the log, no matter what the base is, and you have two things being multiplied, you can split those up, and basically you split them up with a plus sign. So log base b, or whatever, of x times y is the same thing of log base b of x plus log base b of y. So for example, if we have log base 2 of 5x, and we're going to assume that 5x is in parentheses, that is the same as log base 2 of 5 plus log base 2 of x. Similarly, the quotient property, if you are dividing in the parentheses, that's the same as splitting it up with a subtraction sign. Both of these properties are actually similar to exponent properties. So if you're dividing variables, you subtract the exponents. Kind of same thing with logs. So log base 2 of y over 4 is the same as log base 2 of y minus log base 2 of 4. And then the power property, if you have an exponent, that exponent, it's the same thing as coming out front and being multiplied. So this example kind of messed that one up. Let's pretend this is x to the 5th. That would be the same as having 5 log base 2 of x. So the exponent comes out front, and it's technically being multiplied in front. So these first several examples, we're going to go backwards. I'm going to give it to you where it's split up. We're going to rewrite it into one log. So when I say condensing the log, we're making it smaller. We're putting it, we want one log. We don't want to have it written twice. So this is log base 4 of x plus log base 4 of y. I want it log base 4 of something. And it's going to be xy, x times y. That's the product property. Number 2, log base 3 of 5 minus log base 3 of z. When I have a subtraction in between two logs, that's the same as dividing them. Log base 3 of 5 over z. All right, number 3, there are 3 separate logs. These tend to get a little confusing. Basically, if your log has a subtraction sign in front of it, it's going to go in the bottom of the fraction. So, log base 10 is just log over the 5 is going to be in the bottom because that one has a subtraction, and the z is going to be in the bottom. So 5z. And the reason for that is I can rewrite this as log of x minus, and then I can put log of 5 plus log of z in parentheses. Think about if this was distributed. So the log of 5 and the log of z, the 5 and z are getting multiplied by each other, but they're both in the denominator because of that subtraction in the front. So I just like if I have multiple logs, separate out, look in front. If it has a subtraction sign in front of it or a negative in front of it, it goes in the bottom of the fraction. Okay. Number 4, anytime you see a number in front of a log, remember that's the exponent. So this is log base 2 of x cubed minus log base 2 of y. And because of that subtraction sign, I've got log base 2 of x cubed over y. Now, one thing I want to mention is this only works if your bases are the same. Notice all of my bases are 7s, so I can do this. If I had 3 different bases, you couldn't do it. Alright, so I know this is really log base 7 of a squared. That 5 goes up there. Log base 7 of b to the 5th. Plus that one is just log base 7 of 4. All of these have plus signs, so log base 7 of a squared times b to the 5th times 4. Generally, you will see your answer written like this. The number in front, 4a squared b to the 5th. Alright. Log base 2 of 5, nothing needs to become an exponent. This 1/2 does. We don't generally leave 1/2s as exponents. Remember, a 1/2 power is the same as the square root. So this is the square root of 6 plus log base 2. A 1/3 power is the same as the cubed root. So this is log base 2 of 5 times the square root of 6 times the cubed root of 8. Now the square root of 6 is not a whole number, but the cubed root of 8 is 2. So this really is 10 square root of 6, because the 5 times 2 is 10. Now if you wanted on your calculator to type that in, let's see, I don't know, this is Eberly's Play calculator, or Play iPad. Let's see, this is the app that you could get. It's the Calculate 84 app, if it will load. Alright, so it was log base 2 log base 2 of 5 plus 1/2, I'm going to put 0.5, log base 2 of 6 plus 1/3. Don't put in 0.3, it's not the same. Log base 2 of 8. And that's your answer. You wouldn't be expected to get that answer, that decimal. But what I am going to check is to see if the answer that I came up with, log base 2 of 10 square root of 6. Notice they are the same. So a lot of these you could check your answer with the calculator when you're practicing, not on the AP exam. Alright, now these it looks like I can't do anything. But I want to rewrite, I still want to condense it into one log. So what I'm going to do with this 2 is I want it to be log base 6 of something. Log base 6 of what is going to give me 2. So remember, we want it to be equal to 2. So 6 to the second power equals 36. Log base 6 of 36 is 2. So what I've done is I have changed this 2 to have a log base 6. And if I type in my calculator, oh no, got an add. Okay, log base 6 of 36 is 2. So I can do that. I just had to make sure what I wrote here was in fact equal to 2. And now I can condense this into one log by making it log base 6 of 36x. So same thing here on number 8. I need to rewrite this 3 so that it has a log base 2. So 2 to the third power is 8. So log base 2 of 8 is equal to 3. So I can switch them up. Log base 2 of 8 minus 5 log base 2 of y. And now I can get it to where my final answer is one single log. So it'll be log base 2 of 8 over, remember that 5 can become your exponent, y to the 5th. Now we're going to expand the logs. So I've given you one single log. I feel like these are easier than condensing. So remember your product property. If you have two things being multiplied, you can switch it up into two separate logs where there's a plus sign in between. So this would be log base 6 of x plus log base 6 of y. Any exponent comes out, and this becomes 5 log base 6 of 3. A cubed root, remember, is the same as having a 1/3 power. So this is the same thing as having x to the 1/3 power, which is the same thing as having 1/3 log base 2 of x. All three of these logs are equivalent. If I put a number in for x and typed all three of them in the calculator, you should get the same answer. This works with a natural log too. We don't need to write it as log base e, just keep natural log. So this is natural log of 3 minus, when you see a division sign, that's minus natural log of z cubed. But it's not fully expanded if we leave an exponent. So this exponent comes to the front. Natural log of 3 minus 3 natural log of z. Number 13 is a little tricky because this exponent is out here on the parenthesis, outside of the parentheses. So I have to move it first. Might be the way. So 5 log of x over y. That 5 goes with all of the logs. So actually, let me back up. This is technically the same thing as log of x to the 5th over y to the 5th. Let me show you. Let's just try 2/3 to the 5th power. 2 to the 5th over 3 to the 5th. They are the same thing. So this might be a little easier to think of it this way. So log of x to the 5th minus log of y to the 5th. These exponents come to the front. 5 log of x minus 5 log of y. If you brought the 5 out in the front like I was originally going to do, you have to remember that that 5 goes with all of the logs. So 14 is similar. You can think of your exponent rules. This is the same thing as log base 3 of x cubed y to the 12th. Your exponent rules, when you raise an exponent to an exponent, you multiply those. So we would have log base 3 of x cubed plus log base 3 of y to the 12th. Bring these out front. 3 log base 3 of x plus 12 log base 3 of y. Number 15 said the function f of x equals log of 6x is a horizontal dilation of the function g of x equals log of x. So basically, from log of x to log of 6x, that's considered a horizontal dilation. We want to show that f can also be written as a vertical translation. So vertical translations have a number added outside. So basically what we want to do is convert this log of 6x to log of x plus something. I know that log of 6x is the same as log of 6 plus log of x because of my log rules. Log of 6 is a number. It's a decimal, but it is a number. Log of 6 is 0.778. So that answers my question. K is a log of 6, which is approximately equal to 0.77815. Alright, and the last thing that we're going to do is called the change of base property. You don't the reason for this property for doing this is way back before we had the nice calculators. Most calculators you could only type in regular log with a base of 10. You couldn't change the base. Like you couldn't type anything in with a different base. Now we can, so we don't necessarily need to use this, but it's still something that's taught. So if I have a log of any base, let's say I have it as a log base 2 of x, I can rewrite that to any base that I want. Okay, and we do that by taking a is the base that I want, right? So let's say I want it to change it to have a base of 5. It would be log base 5 of this number divided by log base 5 of your old base. So 16 and 17, I want to rewrite so that it has a base of 10. So formula-wise, that's my b, that's still my x, and 10 is my a. So 10 is the base that I want it to be. So this is the same as having log base 10 of x divided by log base 10 of 4. Now be careful, you're like, oh, well that's log base 10 of x minus 4. No, you've got your properties kind of backwards. If you have two logs being divided, there's no way to condense them into one right now. You just leave it like that. Now you can write it as log of x divided by log of 4. So number 17 would be log of 9 divided by log of 5. All right, last question. Let f of x equal log base 4 of x and g of x be log base 9 of x. Show that f is a vertical dilation of g by finding a k to where there's a number multiplied in the front. Okay, so these clearly have two different bases. So I'm going to work with g, and I'm going to convert it to have a base of 4, and then see what happens. So log base 9 of x, that's the same thing as having log base 4 of x over log base 4 of 9. Let me go back to some very basic algebra for you real quick. 10 divided by 2 is the same as 1/2 times 10. Do you agree? 10 divided by 2 is 5.5. 1/2 times 10, 5.5. So x divided by 3 is the same as 1/3 times x. So back up here, when you divide by log base 4 of 9, log base 4 of 9 is like 1.58. So dividing by that is the same thing as having 1 over log base 4 of 9 times log base 4 of x. This right here is just a number. Let's do it. 1 divided by log base 4 of 9. It's literally a number. So it's taking some number, some decimal, 0.6, times log base 4 of x. So my k, that's k. It doesn't look like that's just a number, but log base 4 of 9 is just a number.